Alright, hi everyone, welcome to my YouTube channel, City of Electrons. And in this video we'll be talking about the Gauss Jordan Elimination method, or the Gauss Jordan method. Now this is similar to the previous video where we did the naive Gauss elimination method. So this is a variation of Gauss elimination method. In Gauss Jordan method, when an unknown is eliminated, it is eliminated from all other equations rather than just the subsequent ones. In addition, all rows are normalized by dividing them by the pivot element. Thus, the elimination step results in an identity matrix rather than a triangular matrix. Consequently, it is not necessary to employ back substitution to obtain the solution. So we'll work an example and see what we mean. Okay. So use Gauss Jordan technique to solve this. Now if you observe, it is exactly the same example with the previous one, just that we are using a different step. Okay, we are using a different step. So here's the solution. So for the first step, we put this in a what? In a matrix. Okay, like matrix form. Alright, so after doing this, you see that we didn't even add this equal to sign. Okay, so after doing this, rectangular. So after doing this, that's step 1. Step 2, normalize the first row by dividing by its pivot element. So usually the pivot element is kind of the first thing, first non-zero digit, okay, coming from your left. So let's normalize the first row, okay, by dividing it by the pivot element, meaning this will divide everything here. So 3 divide 3 is 1. 3 divide this will give you this guy. 3 divide this will give you this. 3 divide this will give you this. Of course, the rest part remains the same. So that's the second step. Okay, I call it step 2A because you will repeat this step, this A. You will do this again and again after normalizing. You will do this after normalizing. That's, you have to normalize each row rather. Let me use that word. You have to normalize each row. So we've normalized this row. What is the next thing? Reduction of x1 term in row 2 and 3. If you look at this, x1 term is just 1 here. So we want to reduce these guys. Make sure these guys are 0, these guys are 0. Okay. So for row 2, in order to normalize it, what will you do? You will say row 2 minus 0.1 times row 1. That is row 2 times the coefficients of x1 here multiplied by row 2. So this is row 2, okay, minus 0.1, okay, times row 1. Okay, so 0.1 times this will give you this. 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 Okay, I think there's a little mistake there. The zeros are too much. We'll go closer. Okay. Alright, so this is 6, 6, 6, okay? This is 3, 3. Oh boy, funny. 3, 3. Okay? Alright, better. So, that's it. 0.1 multiply that. So this is kind of a formula, okay? Look at it. Alright, so when you subtract this from this guy, you get this point, okay? Now, the next thing to do is to what? Also, for row 3, to eliminate x1 term or to reduce x1 term in row 3. If you observe, this one now, the x1 term now is what? 0. Are you seeing it? So to do that, we have done that to row 2. So to do it to row 3, we do what? We say row 3 minus coefficient of x1 in row 3 multiplied by row 1. So this is row 3. So 0.3 times row 1, here's row 1, look at it, 0.3 times this, 0.3, 0.3 times this, you get this, 0.3 times this, you get the next thing. Okay, you get the next thing, 0.3 times the next thing, you get that. So it's just the same process, but we'll repeat it. So when you subtract it, you get this part. Okay, you get that part. What's happened there? Why is this thing rough? Okay, yeah. So this, after doing all these things, this will be our new matrix. Okay, after when we normalize, we got this. When we eliminate x1 term, we got this. When we eliminate x1 term, we got this. Okay, so these are new metrics. Now the next thing is to repeat step 2 and 3, meaning we are going to normalize row 2 and repeat the process again by dividing by its pivot element. The same process, but we are going to repeat it for step 2, repeat it for step 3. So for step 2, what is the pivot element? The first non-zero digit coming from your left is this guy. So we divide everything in row 2 by 7.00 by this, okay, that number. So when we do that, we'll have this as our new row 2. However, this guy remain the same, this guy remain the same. Now we are going to reduce this term and this term. Are we seeing what's happening now? So reduction of x2 term in row 1 and 3. This is x2. So x2 term we are going to reduce in row 1 and reduce in row 3. By doing what? For row 1, we say what? Row 1 minus coefficient of x2 in row 1 multiplied by row 2. Because row 2 is the row we are dealing with now. It's the pivot row. Let me use that word, okay? It's a row that has a pivot element, okay? So with that, row 1, this is row 1. 0.3333 multiplied by row 2, you will get this result. Okay, when you do that subtraction, you will get this answer. This is your new row 1. Let's go to row 3 and do that. So for row 3, same formula. Row 3 minus coefficient of x2 in row 3 multiplied by row 2. That will give you this answer. So of course row 3, this row 3 minus this answer is this answer. When you subtract that, it will give you your new row 3. Thus, this is the set for our new row 3. This guy, and this guy. So the last row to normalize is row 3. So to normalize row 3 by dividing by its pivot element. Of course, the first non-zero, which is this. So that will give us this as our new row 3. Okay, and then we are going to what? Reduce x, because we have x3 term here, so we need to reduce the x3 term from the row 1 and row 2, So the same formula for row 1, we say row 1 minus coefficient of x3 in row 1, multiplied by row 3, which has the pivot element now. So this is row 1, this is row 1. So minus 0.068668 multiplied by row 3 will give you this result. When you subtract them, you have this as your new row 1. So let's go to row 2. So for row 2, we say row 2 minus coefficient of x3 in row 2. Okay, multiplied by row 3. So row 2, look at row 2 here. 0.04188848 multiplied by row 3 will give you this result. When you subtract them, you get this answer. Okay, so thus this is our final matrix. Now if you look at it, you see in the diagonal you have 1 1 1 1. This is an identity matrix. Okay, and if you think of it, this is equal to, this is x1, because 1 times x1 term here is x1. x1 plus 0 is same as x1, equal to this. So truly x1 is equal to this. x1 here is 0, x2 here times 1, so x2 plus 0, x2 everything x2 equal to what? Minus this. So it makes sense. 0 plus 0 plus 1 times x3 is what? x3 equal to 7.00. So it's correct, makes sense. Okay, so this is our final answer, and you can see it's the same as the answer we got in the previous video. So we'll stop here for this, and yeah, thanks a lot for watching, and see you in the next video. Bye for now.